Hi, my name is Alexander Azimov. I'm from Yandex, and I hope that everybody that is interested in BGP security have got back to the room. We'll not wait for any other people. So, speaking about BGP security, for years there were predictions that BGP can be used for, with malicious intent. BGP can be used to intercept your traffic. Unfortunately, during previous years, these forecasts came true, and there were already several successful attacks on financial organizations. We do not know the number, the exact number, because there are some public information, there is some private information, and some financial organizations are not going to share that they were hijacked or the data of their customers was leaked. So, what do we have to fight the intruder? So here's the example. There was a network that for years was constantly hijacking address space from other parties. And a year ago, this activity was finally reported at NANOG mailing list. And in a month, this network was fully disconnected from all its upstream providers from access. So when the community showed its power, it was able to disconnect the attacker. But does it really scale? Imagine that we will have not one attacker, but 2 attacks, 3 or 4, maybe 100 attackers simultaneously. And by the way, this attack was not smart at all. So what I'm going to do, I'm going to discuss with you different options that we have to fight attackers from the technical side. So I will be listing these options one by one. Some of them are common, some of them are new one, and some of them can even resemble one each other. So let's start with the first one, which is should be familiar that you should be familiar with. It's of course IRR filters. IRR filters is a way to translate IS sets into a list of prefixes that you should apply at your links with customers. So it's just a prefix list, some kind of prefix tree, and it's quite useful. So let's see how it's working. This very simple topology, I will use it during all the slides. So, and I will spend a couple of seconds in detailed description of what is going on. So here it is Autonomous System 1, which takes IP transit from Autonomous System 2. Autonomous System 2 and 4 both take transit from Autonomous System 3. And during the slides, Autonomous System 4 will try its best to hijack address space that belongs to Autonomous System 1. So, in a simple situation, when there is a root object that belongs to Autonomous System 1 and Autonomous System 4 will try to advertise prefix that belongs to Autonomous System 1, Autonomous System 3 will be able to detect it because there will be no match with IRR filters that should be applied between 4 and 3. Unfortunately, there are a lot of ways to bypass IRR filters. There is a number of databases that are, where you can create root objects without any authorization. You can add any autonomous system in your IS set, and there is never authorization. You can even add Google IS set or IS level 3, and it will be okay. So there is no problem to bypass IRR filters, and most of them are already outdated. So what other options do we have? So just to summarize, IRR filters are useful. They can stop some mistakes. They will help you to secure your network, but they are not suitable to fight malicious activity. And if I imagine about a bicycle that represents IRR filters, I will think something like this. It's hard, it's old, but we have to use it, we have to ride it. And let's discuss what other options do we have. So the next one is role validation procedure. So I'm not going to discuss API infrastructure. In simplified manner, we can think about RPKI as a distributed database of signed objects, where you can easily get cache to use it locally. So how does it work? There is a raw validation procedure. It takes prefix and first autonomous system number in the IS path. And it takes candidates rows where there's a prefix overlap with prefix from the root. And if the candidates list is not empty, then it checks that there is an overlap between list of autonomous system numbers and the autonomous system number at the beginning of the IS path. If there is an overlap, the outcome is valid. If there is no overlap, the outcome is invalid. So it's quite simple. So how does it work? How does it help the user? Again, let's imagine that attacker have already bypassed IRA filters. But now, if it will try to advertise prefix from its own autonomous system number, it will be filtered because the prefix, the outcome of raw validation procedure will be invalid. Unfortunately, it's not enough to stop the attacker because it can add autonomous system 1 in the beginning of the IS path. And with this, autonomous system 3 will be forced to accept this prefix. So, speaking about rows. Again, rows are very useful. They can be, raw validation procedure can be applied not only on customer links, but also at links with providers, peers. So it's provides you much more functionality compared to IRA filters. But without IS path verification or validation, it can't be used to stop malicious activity. And again, bicycle for rows, we have half of it. And we need an opportunity to verify what is in the IS path. And to solve this part of the problem, it was supposed that this part of the problem will be covered with BGP-SEC. BGP-SEC is a quite new protocol. It's 1.5 years old. But already it has a long history and tons of documentation. It's one way call it even a new version of BGP because it has significant changes in the message specification, in the IS path representation, and so on. So the basic idea of BGP-SEC was that the sender signs direction in which a prefix is sent. And so in this case, attacker is able to replay IS path, but can't get inside. So again, we'll get back to the example. Once again, if autonomous system 4 will just advertise address space of autonomous system 1 from its own autonomous system, it will be detected using rows. If it will then try to create a signed signature, it will be invalid. So, does BGP-SEC solve our problems? Unfortunately not. Because the problem is backward compatibility. As I was telling you, BGP-SEC is nearly new protocol. It should provide backward compatibility for old-style BGP. And to bypass BGP-SEC, the attacker needs only one thing. Do not use BGP-SEC. So, rather easy from the attacker side. And the other problem of BGP-SEC is deployment. It has great computational overhead, and so without incremental deployment, and so it's bringing you a lot of expenses and gives very little back. And if you ask again, comparing protocols with bicycles, it will be something like this. It has fantastic design, but brings you nothing than additional complexity. So, something strange with timer that I'm saying for, okay, no, never mind. Let's speak about another mechanism that was before a competitor of BGP-SEC and even was introduced before RPKI. So it was called SOL BGP. SOL BGP was suggesting to use, instead of strong cryptographic validation, verification using external database. So ISPs were supposed to say, to list other ISPs that they are connected with. If there is both ordered pairs exist, the pair is trustable. If only one pair exists, the pair is not invalid. It's just less trustable. So the result is that SOL BGP was not providing a solution that gives clear statement, invalid or valid. It was providing a function that at a high adoption rate may be useful. But again, it can easily be abused by attackers, especially at state of early adoption. Another problem is access. IXS prefer to say that they are not participating in routing. This position is arguable, but it happens, unfortunately. And transparent IXS are not adding their autonomous system number in the path. So with these indirect agencies, there is impossible to create such a database. And there is another option for attackers. So as a result, SOL BGP is a function. It's capable to detect bogan routes, but it's not capable to detect route leaks or is not capable to provide a general solution to verify IS path. And behind all its disadvantages, SOL BGP had at least one bright idea. Verification, which is done outside of BGP protocol itself, is is less costly than cryptographic validation. And so, anyway, we're here. At the moment, there is no mechanism that can save us from malicious activity. There are several mechanisms that are designed to detect mistakes and nothing to detect hacker activity. So, but we should accept it and move forward to a new BGP extension, new BGP solution, which will finally solve our goals. Because otherwise, we will be doomed to fight attackers using mailing lists. I don't think this is acceptable for the community. So let's specify the goals, because properly specified goals may bring us a solution. We need to stop propagation of malicious hijacks and route leaks. We need to cover both situations. The technique should support incremental deployment. It should be lightweight. It should not require significant updates in the BGP protocol itself. And of course, it should provide fully automatic solution. So, let's speak about how anomalies are propagating. Is there any difference between propagating normal prefix or hijack prefix? Of course not. It propagates to upstream providers, to peers, and then to downstreams. And if we will be able to detect this propagation at the level of links between customer and providers and peers, we are done. So we can simplify the work. Instead of making a goal to verify all IS paths in the world, it's enough to verify IS paths for prefixes that are received from customers and peers. And there is another beautiful note for this. For prefixes that are received from customers and peers, all pairs of different autonomous system numbers in the path must be customer and to provider. So what we need is a distributed database of signed objects that will say that this is my providers. And here we're getting to API again. So what we are suggesting is a new API object that will give ISPs an opportunity to list their providers. With this object, it will enable other ISPs to detect hacker activity for the address space. So here is an example. So there is a customer autonomous system that signs who is its provider. The verification procedure is very similar to role verification. So again, we are separating, we are splitting IS path into pairs where prepend values are ignored. After that, for each pair, we are retrieving candidates as pairs. If the list is not empty, we are checking if there is an overlap. If there is no overlap, then the outcome will be invalid. If there is an overlap, the outcome will be valid, just as rows. So let's see how it's helped. Once again, if autonomous system 4 will advertise prefix from its own autonomous system number, it will be detected using rows. Now, if it will try to add autonomous system 1 in the beginning of the S path, it will be detected because autonomous system 1 have authorized only autonomous system 2 to send its prefixes to upstream providers. It may get, autonomous system 4 may then try to add autonomous system 2 to the IS path. Again, it will be detected because autonomous system 2 have authorized only autonomous system 3 to send its prefixes to upstream providers. The last chance is to remove autonomous system 4 from the IS path at all. But according to the specification, the router must check that the neighbor autonomous system number is present in the IS path. Here is the result. User always wins, or at least nearly always. There is still the only opportunity for an attacker is to be your provider. This is the last limitation, but it is very unlikely that a person that, or a legal entity that you have, that have a contractual agreement with you will start attacking you and hijacking your address space. I suppose that you will break such contractual agreement in a very little time. So, ASP, it's very simple. It works for both hijacks and route leaks. It's for both malicious and mistakes. It doesn't require any changes in the BGP protocol. It's, the basics is on API infrastructure that must be slightly updated. And of course, it works also at the state of earlier adoption. And here is how our security quadrant may look one day. Here's our drafts. They are already published and adopted by CyberOps working group. There is a list of authors that is actively working on these drafts, but this technology will not work without your support, because BGP security or insecurity is our joint effort. You should do your part of the work. You should integrate roles. You should sign it. You should push IRAS because APK infrastructure heavily relies on IRAS infrastructure. And for example, as you all know, ARIN is slightly behind in this process at the moment. Here we are. This is a possible future, a simple one, where we may be, where BGP routing will be secured. We are in charge to decide, will it happen, or will still solve the problems in the mailing list. Thank you for listening. Any questions?
Hi, can you hear me? Okay. Hi, my name is Paweł Karkoszka. I'm from F5 Silverline. And I have a question about the solution that you proposed here. Is there an option for provider to be also listed as a customer, as the origin AS, or do we have to have two RPKA entries in for such a situation?
So I'm speaking about sibling relations when both parties are in one region, one is customer of one party, in another region, one is customer of another party. I'm speaking about this situation.
Yeah, why I'm asking, because we have a solution that we call route origination. In this situation, some of our customers want us to advertise their prefixes as we are the origin AS. For such a situation, do we have to create two database entries for the RPKA, or can we, as a listed provider, be also an origin AS in one entry?
If you have a valid role for prefixes that may belong to your customers, you don't need to create anything except ASPA, like for your own address space. So ASPA is not per prefix. It's per autonomous system number. And in your case, it will be working from box.
Okay.
Nothing to worry.
Okay. Thank you very much.
You're welcome.
Nimrod Levy, AT&T. I just wanted to first thank you for pushing these proposals through. This is some very good technology to help improve the routing in the internet. And I wanted to make one clarification that there are, in fact, transit providers filtering on ROAs.
Yeah, and as far as I remember, AT&T is dropping invalids already from, at least from peers.
That's correct.
Yeah, and it's great news, and I hope other tier ones will join this party.
Yep. And if there are any questions on that, that anybody wants to talk about what we've experienced in that regard, I'm happy to have those conversations as well.
Yeah. I just want to highlight one more time, it's important you to start at least considering using raw origin validation inside your network. There are already several open source implementations, I know at least 3, from Rive, from Cloudflare, and from NL Labs, that can be used inside your network. And you need to understand that ASPA will be easily integrated on top of this infrastructure. It's you're investing one time, and when the ASPA will be on fly, it will be much easier to integrate it. Any other questions? So, thank you very much. Thank you for suffering from my Russian accent, and see you around.